All right, here are your notes for reasonable, domain, and range. So the first two words that we need to talk about are what it means to be discrete and what it means to be continuous. Discrete are values belonging to the set are distinct and separate. All right, so what do I mean by that? I'll just give you some examples. The number of students in class. Okay, the number of students in class, you can't have a fractional amount of students in class. Okay, so that's what it means to be distinct or separate. You're going to have whole numbers only of students. Or another example is how many TVs you have at home. All right, you may have no TVs at home, you may have one, you may have two, you may have three, four, five, but no one in here, no one that I know of, it's impossible to have 1.28 TVs at home. You're either gonna have one, two, three, or four. You're gonna have whole numbers. One more example is something like the number of candy bars you could buy with $10. You can buy one candy bar, you can buy two, but you can't buy 2.3 candy bars. It's not possible. Okay, so an example of what that would look like on a graph would just be like a scatter plot. Okay, so just a set of points, and they call that a scatter plot. The opposite of that would be continuous, and these are values belonging to the set, can take on any value. So mostly what we're talking about is any value meaning decimals. Any value within, but it does have to be within a finite or infinite interval. We've been talking about interval notation, okay? Examples of this: the height of a person. You could be 50 inches tall, you could be 51 inches tall, you could be 51.25 inches tall. That's possible, right? Another example would be like the time to complete homework. It could take you 1 hour, it could take you 1.22 hours. Decimals would be included there. So there's another example of continuous. I'll give you one more. The outside temperature. Right? It could be 90 degrees, 90.1, 90.1111 degrees. So those are examples. So what that looks like on a graph, just an example would be a continuous line as opposed to just different points. So the key here is points are connected. So that's discrete and continuous, the difference between the two. So a lot of these are going to be word problems because it'll be what's reasonable given this word problem. So the first one, Martha wants to purchase a variety of bracelets to match her new wardrobe. She has $122 to spend, and each bracelet is $5. How many bracelets could she buy? Well, I think most of us would agree. We just take 125 and we divide that by 5, and we get 24.4. So what's the independent and dependent variable? The independent variable is going to be the total dollars. The dependent is the number of bracelets. What helps me understand this is dependent, the number of bracelets depends on the amount of money you have, or the total dollars. So the dependent variable is the number of bracelets. Now, is this going to be discrete or continuous? This one is actually going to be discrete. And the reason for that is because can you buy a decimal amount of bracelets? No, you can't, right? Just like the candy bar example. You can buy one bracelet too, but you can't, it's impossible to buy a fraction of a bracelet. All right, so let's do reasonable domain, the total dollars spent. Now, you could spend, if each bracelet's $5, you could spend $5, you could spend $10, you could spend $15, but it's impossible to, first, let's say, to spend $2.2. And the reason you can't spend $2.2 is because bracelets are $5, right? It's impossible to spend $2.2. So this is tricky. So what you don't want to do is this: 0 less than or equal to X less than or equal to 122. Because what this statement says is that you could spend everything between 0 and $122 because that's how much money you have, and all the decimals in between. That's not possible. All right, so you have to list them all out. So if you don't want to include all the numbers in between, here's one way you could write it. Use braces. You could spend, the lowest you could possibly spend is 0. You want to start at the lowest. You don't have to buy any bracelets, right? So you could spend 0. If you buy one bracelet, that would be $5 would be a possible amount you could spend. You could spend $10 if you buy 2, and 15 if you buy 3. And I could keep going, but I'm gonna hit ... So what they'll do sometimes hit ... You don't have to list them all out. And what you want to do is hit ... Well, what's the most you could possibly spend with the $122? Now, you initially want to, the first thing you might want to put is 120. You could spend $122, but that's not the case. The most you could possibly spend is 120. Okay, because 120 is a multiple of 5. So you could spend $120, which would actually get you 24 bracelets. Okay, so what's the reasonable range? Range is the number of bracelets. Well, we could receive 1 bracelet, 0, and 1 bracelet, and 2 bracelets, ... The most we could get for the number of bracelets is 24. 24.4. We don't have enough money to get 25, so we're going to say 24. So that's an example of what it means to be discrete for reasonable with these word problems here. The second one, Kimberly's playing on a trampoline. The mat of the trampoline sits 3 feet above the ground. So I'm not an art major by any means, but hey, here we go. We have a trampoline, right? And it says the trampoline is 3 feet above the ground. So this is 3 feet. As she lands on the trampoline, the mat flexes 2 feet down. That means when you're here, it actually goes down 2 feet. And springs her in the air at 9 feet. So she can get up to 9 feet. Additional 9 feet above the trampoline. Okay. Find Kimberly's height. This should be above the ground over time. So our independent variable is time. That's almost always the case, especially if you take a lot of in science class. They usually probably have the dependent, the independent is time. The dependent is height. Your height's going to depend on how much the time since you're jumping. All right, is this discrete or continuous? Well, can you have a fractional time and height? You can, right? You can be on the trampoline 1.2 seconds or 1.2 minutes. You can be 3.4 feet above. So this one would be an example of continuous. All right, reasonable domain. So what's the least amount of time that she could spend on this trampoline? 0. She could spend 0 minutes on the trampoline, but that's the lowest. She can't spend negative time on the trampoline, right? Well, what's the highest the most amount of time she could spend on this trampoline? And that's kind of hard to answer, right? We could argue all day about, well, if she gets tired, maybe it's this many hours or that many hours, but there's really no max here. So I'm just going to put anything greater than 0. I mean, it's really hard to say. So, but the key here is nothing less than 0. You can't spend negative time. What's a reasonable range for her height? Now, this is going to be bounded because you got to think reasonable range, just like you would domain. What's the least? What's the most? Reasonable range. What's the closest? The shortest height above the ground she can get? And the answer to that is 1 foot. And the reason it's 1 foot is because if she initially starts at 3 feet, the trampoline's 3 feet, and it flexes down 2 feet, that means at this point, that would be 1 foot above the ground. Her feet would be at 1 foot, okay? Now so I'm gonna do 1, we're gonna use y. What's the most? What's the highest? Now we're not gonna use infinity here, all right? Because it tells us it springs her 9 feet in the air. So if she was at 3 feet above the ground and it sprung her 9 additional feet, that'd be a total of 12 feet above the ground. So that's an example of continuous. All right, one more word problem. Elaine is in the business of repairing home computers. She charges $50 for each visit and $25 per hour or part of an hour for her labor. A lot of businesses will run like this. The total cost for a home visit and X hours of labor is multiplied by this function right here. Okay, is this discrete or continuous? Well, the answer to this is actually going to be discrete, and I'll explain here in a second. So, if we're thinking of a reasonable domain for the amount of hours of labor she could work, okay, she cannot work negative hours. She could work 0.2 hours. She could work, 0.8 hours or 1 hour or 50 hours. So there's really no limit, but there is a limit on the lowest end, and that's 0. So I'm just going to put x is greater than or equal to 0. We can have decimal amounts for time. What is a reasonable charge for the total cost that she could charge? Well, if she doesn't work at all, I would say the least amount is 0. 0 hours. Now, can somebody be charged $1? And the answer to that is no, because the initial charge is $50 and $25 for every hour or part of an hour. What that means is if a customer asks if she works for half an hour, what she's going to charge is the initial $50 plus, because a half an hour is part of an hour, she's going to charge $25 for that 1 hour. And like I said, a lot of businesses will work like this. If they go to your house for one hour and 1 minute, they usually sometimes will charge you 2 hours. So this is $75. That's anything up to 1 hour. But what if you go above 1 hour? Okay, she's going to charge you $50, but now she's going to charge you 2 of those 25, which would be 100. And what if it's between 2 and 3 hours? She's going to charge you $125. It is impossible to be charged, let's say, $90. That's impossible. It has to be one of these. So I'm going to use braces here for the range. The least amount is 100, and because this is a discrete, I'm not going to use an inequality. I'm actually going to list out the possibilities. So 0, then 75 is the next least amount that you could possibly be charged, then 100, then 125, then where do we stop? I mean, what if she works for a customer for 1,000 hours? You may say, that's not possible. Well, then technically it is, right? So we don't know where the end of this is, so what we can do in this situation is hit ... and we don't know the end here, so I'm just going to leave it with ... All right, so that's kind of a very unique example of kind of continuous and discrete kind of mixed together, but that's what it would look like there. All right, 2 more for you guys. Next one, Eduardo tosses a ball in the air. What is a reasonable range for the height of the ball? So you toss a ball up in the air, obviously the ball goes up and it comes down and hits the ground. Now, even if that ball, you toss it at ground level, it's going to go up, it's going to come down, it's going to hit ground level. Okay, ground level usually means a height of 0. All right, so the lowest that this ball could possibly go is 0 feet. So the answer of all real numbers, that includes negatives. That is not possible. Okay, the ball can't be negative feet in the air, or negative meters, or whatever it is. B, -4 to 20. That's also including some negatives. I don't like that. C is kind of tricky. Can the ball be 0 feet in the air? Yes. Can it be 1? Yes. 2? Yes. 3? Yes. All up to 20. Yeah, that's possible. But what this is missing is this only includes the integers 0, 1, 2, 3, and 20, and not the decimals in between. Can the ball be a decimal amount of feet in the air? It can. It could be, at some point, it's going to be 0.5, then 0.54, 0.56. It could be 8 point, whatever. So this does not include decimals, so I don't like that. This one here, 0 to 20, and all the decimals and every number in between is a possibility. All right. The last one, an arrow shot upward at the initial velocity of 120 feet per second. The graph shows the height with respect to time. Is this discrete or continuous? Well, because it is a continuous line connected by dots, that tells me it's continuous. Also, because an arrow can be a fraction, this is height over here, and time. Because height and time, you can be fractional amount of height and time, that would also imply that it could be continuous.